Hi everyone, this is a take on the very famous balancing robot based on Multiwii and Arduino. So in this video I'm going to show you how to build one, and hopefully you can build your own. There we go. So okay, we have everything that we need to put together the board, the components. So I'm going to go through one by one and describe what they are and what they do. And I'm going to try and put some links that you can maybe purchase them online through eBay or some other sources. We start with the Arduino Nano. This is the standard, well, there are clones of them. They're not very expensive. I think if you buy them bulk, you can get them £3-4 each. They have a USB connector and the basic Arduino chip on there. So that's the first thing. The other one is the drivers, the step motor drivers. These are A4988 drivers, so they all come as well. You can get them soldered or you can buy them without the headers. But what you need to do is, if you can see, there's a little tripod there. You need to adjust it according to your stepper motor, so I can give you more details on the description on how you can do that. There's lots of videos on how to do that. It's quite straightforward but a bit fiddly job, but you have to do that, otherwise you can either burn your end motor or you could just lose a lot of power going to the motor. The other one is the CCPM compatible DSM2 radio receiver. So the links that I've shared, the guys who put this together previously, they haven't used RC control, but the software allows you to do so. So I'm going to set up the both configurations. You can either use it with a radio, RC radio, DSM2, mostly Spectrum I use, or you can also use your Android mobile phone to control it. So this is the CCPM receiver. We have the accelerometer. So this is the accelerometer chip, which is MPU-6050. It's quite cheap module, and it worries how you position this on the robot. So depends. You can change it through the software, but go with my description so it's easier, because if you get it wrong, the robot will never balance, because it's gonna get its X's and Y's confused. We need a diode for making sure that the motors don't leak back current to the chip. We have some resistors, actually 4 of them, 500 ohms, 33k and 51k. We have 2 LEDs. One of them is basically an on one, and the other one, I don't use that one actually, but you can use it for low voltage and other things. You can configure the software if you want to. Obviously we have to have a Lipo. That's a 3S Lipo. You can get bigger ones, but Arduino don't want to go over 1816 volts, so stick with this. This is 11.1. And some headers. Obviously this is, you have to cut them according to where you want to put them on the board. So instead of soldering the component straight to the board, I'm going to use those headers, put them in, and then if something goes wrong, you can always change the component going forward. Yeah, and the motors, obviously this is a Nema 17, I don't know if you can read that, stepper motor. So this is a retro design that I've done, and I've tested the circuit with the breadboard on there. So what I'm going to do is make this one working now. So these are, you can also get these little hardware to screw that on the board there, on the wood. And yeah, so you have to have these couplers for the wheel, but yeah, you can go around it. It's about 10 centimeters. That's the diameter of the wheel. So stick with those measurements. That is all described on the previous video that the chaps have put together. And this is a Android phone. You can you need the software for that. And the last thing, I put a little funky light, LED light on the previous robot, so I'm going to do the same. This is not on the board, so you have to put a resistor and solder this in. You don't need that, but yeah, that's a funky thing, and it's when the lights are off, it's quite cool. One more thing though, I've realized that I missed to put those capacitors for on the connections to the stepper. So if you don't use those capacitors, you will burn those drivers. Basically, I burnt a lot of them until I figured out that that's what's required. This wasn't on the design that the guys shared, so this is basically me researching and finding out that's something need to be added. So this is not on the board. So what I'm going to do is solder those at the back of the board, such as this. I'm going to show you which pins they need to go. These have polarities, positive and negative. So it's not a big deal, just 2 caps you need to add once you have soldered everything in. So there we are. Obviously we have the Spectrum. I have a Spectrum, but yeah, DSM2 Radio to control the robot. So there we go. So let's start building. Yep. I need to cut this as well. So you get the idea. So you have to solder them back. So okay, I have cut the headers, as you can see, and just positioned them so that I know they are all in the right length and they're in place. So also I put the JSD sockets in so I know where is everything is going to go. And also we have a different type of header for the radio. So this is a male one, and that's the power JSD. So I'm going to give another update before, but make sure that you put this in the opposite direction as the image is on the board, because I don't know why that component was not correct. So it's not this way as it says, as it shows on the board there. It should go the other way, and the positive and negative are different, so be careful with this. Okay. So what I'm going to do, I'm not going to solder them now because I need to, it's easier to solder these passive components first, the diode and the resistors. So I'm going to do that first, and then maybe the LEDs as well, and then I will put the headers on. So this is the diode. Make sure that the negative, you can see maybe inside there's a bigger piece, and the shorter leg is negative, so it have to go on the board where the minus is. So make sure you put it that way. Same with that one. That's the short one. Just go on to the minus. So when you solder it, make sure it just lines up with the board. Okay. Now we can start soldering the headers. And again, make sure this is straight, because you can also always bend it a little bit, but make sure that you're putting this straight, because this is the accelerometer and have to stand straight. You can always calibrate it with once the model's built, but it's best to make it straight. So. That's good. Okay. Okay, so remember, this is the piece that's going to go like that, not like that, like that. Okay, I have to press these. So there we are, we're almost finished. Okay, no, not really, we have to add these as well. So there we have all the necessary soldering done. The headers, you can see there's more expansions such as the B port, A port, or another extension here, which I just remembered I have to add for the Bluetooth module, so I'm going to just do that quickly. Okay, so this is the last header for the Bluetooth module. So there we are. Board is ready. So we're going to put the components in. So okay, last bit of soldering. If you remember, I mentioned the capacitors that needs to go in. So they need to go between the pins ground and VMOT, which is the voltage, the high voltage that comes from the Lipo after the diode. So this goes in on the board this way. So when you turn it around, it's basically these two pins here that you need to solder the cap, and the negative is that way. So I'm gonna share the correct schematics so you can have a look. But what I've done, I have bended the legs such as this so it's easier to solder. So I'm gonna try and put it like that. It's a bit difficult trying to video at the same time. Get a bit of solder. Maybe a bit further in, yeah. There we are. And a bit more on this side. So, yeah, I have shorted those, which is not good. Be careful not to. So what I'm going to do, I'm going to try and push this whilst I'm it's not going to be easy, so let's try and use that. It's not the best solder, but it will work. Yeah. Actually, I might. No, I could maybe. Yeah. Yeah. Okay. Cap to the other cap. So let's bend it. Yep. there. Okay. Not the easiest job, but maybe I can upload a better updated schematic so that the caps will be on the board, so you don't need to worry about those kind of stuff. Yeah, looks good. So there we have it. So there we are. We've done all the soldering, the base components and the headers. Now, like I mentioned, the caps are all in place. Make sure that you don't solder them, that you don't make a shortcut on those. And the polarities, like you see the minus polarities towards that way of the board. Now, what we need to do is put components in. Let's put the accelerometer first. Goes in this way. And Nano goes this way. Okay. And we have the drivers. They go this way. Yeah, the Bluetooth module goes this way, and the CCP goes, let's make sure that we got this correct, the the brown would be on the right side, so the yellow would be on the left. So that's how you plug this in. There we have it. Now let's plug it into the computer through USB and program it. So I mentioned about the software that you can see if everything's working fine. So let's plug this USB back in. Okay, let's put the module here, and you go ahead and open the file that is called, which is in the application Windows 32. It's called the Multiwii conf. This is a Windows application. Okay, so you have a dashboard, and you have certain COM ports that depending on which COM port you're in. As I mentioned earlier, mine is on COM 10. I choose COM 10 and I press start, and it should start reading the information coming from the module. So every time I move the module, you can see on the screen here that it is feeding all the information that is coming from the accelerometer in terms of the roll, the pitch, and all that information is there. And also this is a good tool to configure the PID values. You can also do that on the Arduino Android phone, but yeah, this is, I think, easier to do. And to change the values, it's a bit awkward. You have to click on the box and move your mouse pointer to right or left to change the values. You can't just type it in it. It's just, I don't know why they did it this way. So, and then you have to press right, so it uploads everything. So also the auxiliary configuration, these are important, how you arm the robot using a Spectrum or other devices. So you have to click the certain settings on the auxiliary configuration, so it should go arm the device, so it should start working. I'm not sure what simple does, but that's how it's configured. And the rise or position hold, you have to play with those. I haven't managed to get the rise working because some of the videos you might see that when it falls down, the robot, it could stand up again, which is the rise mode, but I think I have to be quite light. Mine is quite heavy, so it's not doing that, but there we are. The position hold is when you gently push the robot forward or backwards, it comes to where it was before, so it's another feature. So there we have it. So okay, now we're ready to put the board on the hardware. So like I mentioned before, this is very basic construction. You can follow the other videos online, that they're almost same, but this is what I had lying around, so that's how I put together. I put this little board, a few kind of couplers, I think they're called, for the screws to go in, and we have the board here, so I'm gonna just put it like that. I'm just only going to use 2 screws because it's not very heavy, so you don't need to do the 4. Oops. And that's the other one. Done. And we have the motor, so the board says left and right, so you can follow the text there. So this is the left motor. I'm gonna try and put it this way so the cables will rest a bit better. That's one, and that's the right motor. Okay, so I can arrange those cables later. I could have done a bit shorter, but there we are. Okay, and we need a Lipo. The Lipo will go on the side here. Try and make sure that you put it like balanced. Okay, there we are. So let's start it. Okay, so you have to obviously bind your radio to your receiver. So these are things that you could find lots of information on how to do that. So you first obviously turn your radio on, and then at the moment of truth you plug in your Lipo. You can hear the motors engaging, but because it's not armed, there's nothing happening, so it's not balancing at the moment, even though it's on, and the lights suggest that when it's ready to, yep, the light's gone off, so it's ready to go. So all I need to do, just remove some of the stuff here so that, arm it. There we have it. So if I turn it, slowly turns. Oops. Well, you have to play with the PID values depending on your model. It could all be different because this is a bit heavy material, it's wood, so it changes slightly, but not majorly. There we have it. See which way it falls. Oh, there you go. Enjoy.